Good afternoon, Twitch. Welcome back. We have another breakout session here for you today. Now we're going to talk about ECS and local testing for containers. Before we dive in, let me just quickly introduce our guests here. We have Utra, Nathan, and Brandon. Can you please each say a little bit about yourselves?
Hi, I'm Uttara. I'm actually a developer management for the developer experience team in Amazon ECS.
I'm a developer advocate on the container services team.
Yeah. I'm Brandon. I could really go for a latte right about now.
Me too.
Lattes all around afterwards.
Yeah.
Cool. If anyone's listening and wants to bring us some
Let's
lattes,
put that order in.
Yeah.
I'll get you back.
So this is a very interesting topic, and it's very near and dear to me because I remember years ago when Docker first came out, the promise was this thing works exactly the same in your local, on your laptop as it does in prod. Now we can stop banging our heads at all those issues that are like, oh, I worked on my laptop, pushed to prod, oh no, everything broke, right? And then in the middle, some stuff happened. So maybe you can walk us through kind of the evolution. How did we get here? What happened to need this kind of feature now?
Yeah, absolutely. So prior to those features, like developers had to go through this really slow iteration cycle. So let's say they have an ECS task definition, they make some edits, they push their code out, and then they wait for that task to come up, and then they match their expectations and see if the task is performing the way they want to. And then suddenly, like they realize, oops, I had a typo. Like that's happened to me a lot. Or they realize their policies are misconfigured. And then they re-edit their task definition, fix their IAM roles, and then the thing starts again until you probably hit another roadblock. And then the cycle is pretty slow. So I'm so thrilled to announce, like with ECS CLI today, you can actually run your local task definition in a local environment like your laptop or your virtual machine. So now suddenly you can test your volumes, you can test network modes, your secrets, your IAM roles, or even the task metadata all locally before you even deploy to production. So this not only saves time, it also makes it more secure. Like you could even have launched some application there with very relaxed and lenient IAM policy that allows for everybody. Expose some ports that you probably don't want to. So by testing your code locally, you can avoid those mistakes, and hence it makes it more secure to do that. And lastly, it saves on costs. Now you don't have to pay for your testing in production. You can just do your testing locally. So those are some key benefits.
Did I hear you say that you can test locally with your volumes?
Yeah. Yeah, it's basically using the Docker volumes driver.
Yeah.
And actually that's a great question and a good segue into how does this work under the hood, Nathan? Can you help us understand that?
Yeah, so let me bring up a diagram that I have here of how this works. So first I want to show sort of the current state of things, how a lot of people are currently doing development. And that is, on their development machine, they have their local container that's running, but they have to manually control how they load AWS credentials into the container or manually get secrets into the container, oftentimes using environment variables. Or maybe they mount, for example, their home directory or a credentials.json file into the container in order to give it credentials to be able to talk to AWS. But that picture is very different from the way things actually work in reality on production. You should see on the right. In production, your container is hooked up to Amazon ECS container services metadata endpoint, which can serve it credentials automatically just based on a role. ECS also has a feature such as the parameter store secrets that you were talking about earlier, which allow you to reference a secret inside your task definition, and then it'll pull that secret in automatically and inject it as an environment variable. So right now, there's sort of this divergence between what really happens when I run locally versus what happens in the cloud in production. And we want to close that gap. So what we're launching today is an ECS local sidecar container, which helps you to close that gap and make your local environment very similar to how things actually work in production. And the way that works is we're providing a tool which automatically launches a sidecar container, which is hooked up with the same interface that your container would normally use in production to talk to the ECS metadata endpoints and fetch credentials or fetch secrets.
So just wanted to clarify for my benefit, is this ECS local container actually talking back to the AWS environment and fetching the real credentials, or is this kind of like a cached a snapshot.
Yeah, yes and no. Currently, what we're doing right now for this first release is it's fetching credentials off of your development machine and vetting them into the container, but it will reach out to Amazon parameter store or secrets manager to fetch secrets and inject those into the container.
I see. Okay,
So it's a little bit of a hybrid
credentials
right now.
locally, and then secrets from secret manager. So
Yes.
it is calling home for that.
Yes,
Got it.
correct.
Got
Correct.
it.
And I want to show how easy this is to work with in the local environment. Let me bring up a sample application. This, if you're familiar with ECS, this is a pretty standard task definition. It just has one container in there that has a port that listens on port 8080. And you can see this is a Fargate task definition. It says requires compatibility as Fargate. So normally this would be completely meaningless to my local host. I can't do anything with this locally. But with ECS CLI, I can actually use this. So the first command I want to show is ECS CLI local. All the new commands that we're adding today are under this namespace local. And if I type PS, it will show me a list of containers I'm running locally. Nothing currently. If I type up, it will generate a Docker composed YAML file and launch my container. And now if I go over to my web browser and look at that localhost 8080, I have an application running. It's a Nyan cat going through the cloud.
I get the impression that you like Nyan cats.
Yeah, I do.
Seems to be a recurring guest in your demos.
Yeah, I mean, I really like this because it looks nice. It's just a little basic web server.
I always get the song immediately in my head too. Whenever I see it, it just starts playing.
Oh, there's definitely audio here, but you guys are lucky. I told them not to pipe the audio from my laptop into the Twitch stream, so otherwise we'd be hearing the music. But what I wanted to show was, it's that easy to launch. And this first level, obviously, this is something we could always do before. It's not adding that much extra capability that wasn't possible. But when it comes to the IAM roles, that's something that was very hard to do before in the past. So I want to show a little Node.js app that I put together. And all this is really doing is it has an endpoint called /identity. And what it does is when the request comes in, it asks to figure out who's making this request. And it uses the Amazon Simple Token Service API with get caller identity. So what this is going to be doing is it's going to be verifying that I have an AWS credentials identity set up when this application endpoint gets called. And so when I run this locally on my machine, I go to task, role, and just node index .js. So this is running now, and if I close this out and go to 8081/identity, you can see that the application which is running directly on my laptop knows who I am. And the way that it's able to do that is the SDK that's running as part of the code looks at my disk location and finds the credentials file and then passes those credentials off to AWS to authenticate me as this IAM user, Nathan. But the story changes if I launch this in a container. So let's say I do this to run that very same code inside of a container, and I'm just running a Docker run command manually. Now, if I refresh this, it says no identity. And what's going on here, basically? Well, the reason why this is happening is a Docker container is its own isolated environment. And the Docker container has its own file system sandbox, basically. And it does not have access to the credentials that are living on my host development laptop. Because the Docker container is in its own perspective, it's its own fresh machine that is just running that. And it doesn't have access to anything else outside on the host. So ECS CLI helps us fix this. So if I close this out, did you want to?
No, go for it.
Oh, okay.
Yeah.
If I do ECS CLI local up here, once again, it's going to launch my container. And if I refresh this again, once again, it says I'm Nathan again. And so the only thing that's different here is when ECS CLI loaded up this container, it automatically set up a Docker network that would attach this sidecar metadata container to my task using the same address that a production environment would. and it allows my container to interact as if there was an ECS endpoint available to it, even though it's running on my local development laptop instead of on an EC2 server in the cloud.
That's pretty
Pretty
amazing.
sweet.
Yeah,
Yeah.
it's definitely a major productivity boost. Did you want to say anything else about other capabilities of ECS?
So as we talked about earlier, like this is a great use case for task IAM rules. Like previously, customers had to do this by actually pushing it to production testing. So being able to do this locally is the #1 value add for this tool. Additionally, like if you, from your applications, were accessing Docker stats by talking to the task metadata endpoint, now you can test those locally as well. So if you like had a different SDK that you were depending on, now you can test that locally so you don't have your application code go through this cycle and wait forever. So in addition to that, secrets, that's super critical, like being able to like pull down your secret and test your application, know that it works completely end-to-end is another really good use case. One of my personal favorites is actually, you know how this actually creates a Docker Compose file at the end of it? You can actually also provide an override file so you can pass some of your local environment's configurations, like you have an environment variable that's dependent on your local, domain and realm and everything. And in addition to that, if you have like application code, in your case Nyancat, that you were building locally, you could actually attach a local Docker file or like mount your source code in and build this and like run this whole entire end-to-end locally. So that's some of the other features that we have support for. You can always like look at our GitHub repository, and we are completely open source. We believe in building in the open. We want to hear from you. If you have like feedback, feature requests, or any comments that you want to talk about, like more local testing capabilities that you would like from us, please like reach out to us on GitHub. So there are a couple of places where you can do that. The Amazon ECS CLI is one of our GitHub's repo where you can do that. Or we also have the containers roadmap where we're actively looking to hear from you guys. I just want to preface all of this to say that we believe in like building best class tooling for our customers, right from like building our applications to testing locally to deploying to actually like observing what's going on. So we want to make sure that that whole experience is seamless and fits all the use cases that you have. So let us know if you want to, like the next feature that you'd want for this.
I also got to say, huge respect for publishing your roadmap, putting it on GitHub. I think that's incredible. I think hopefully it works very well so we can convince more service teams at AWS to do the same thing, because I think it's fantastic.
It's already starting to happen to some extent. And all the teams that I work with on the container side and CDK side are really reactive to any issues you open on the GitHub repo. So I want to show, if I can bring up my screen again, the actual repo for the ECS local container endpoints. And this is the code for the sidecar container that runs locally on your development laptop to provide all these production features to your local container. And as you can see, there's issues you can open up on it, and there is a list of the different features that are made available. So if there's a feature that you would like to see us add to this local environment, feel free to open a pull request or an issue on this repo or on the container roadmap.
Or the ECS CLI.
Yeah, or directly on the ECS CLI. Repo.
Open an issue. I think you mean submit a pull request, right?
Well, you
Both.
ideally both, but we also accept just issues by themselves if that's what you have.
So we've got a lot of audience members with a bunch of questions. Some
Okay,
of
let's
them
go
are
for
like, what is AWS? Some of them have no idea what containers are. Some of them don't understand if you're just testing the container itself or everything that's running in it. So there's a lot of confusion, and we have some time. So I think we should break down some of these concepts, help share some knowledge with some of our viewers. So I guess to start off, AWS is Amazon Web Services. It powers a large portion of the internet. It's cloud computing. It's IT infrastructure available as a service. Pay as you go, spin up servers, use them for what you're building, power them down. So it's really a way to focus on building the things that differentiate your application rather than trying to be an expert in managing IT infrastructure. So anything I missed?
Well, so
I guess you kind of have to know what cloud computing is.
I would say starting from AWS, the next thing is like, how do you actually run a program? Because everybody knows how to like run a program locally on their computer. If you want to run a program on the cloud, it's a little different. That's where the container comes in. I don't know, you want to explain a little bit about containers?
Yeah, containers in general is this technology that enables you to package all the container, the application itself, and all the other dependencies with it in one construct called a container image. And what that does is it makes sure that that image itself is portable. So whether you run it on your local machine or whether you run it on the cloud, it behaves the same way. So this gives you the flexibility and the portability that you need for your application. So it, again, coming back to like, if you tested it locally, it should behave the same way you test in production. So this completes the whole story for Amazon ECS. And to elaborate on what Amazon ECS is, it is a way for you to run these containerized application using Docker technology at scale. So you say that here are a bunch of servers that I have, and here's the applications that I want to run. And Amazon ECS sort of puts and places all these containers on these resources, and if your containers die or if your instance dies, it brings all of that back up, and it has nice auto-scaling capabilities and like wide range of integrations with the AWS ecosystem.
And so the reason why containers running locally is a particularly interesting problem is because as one of the people were asking, you know, what are you testing locally versus testing outside the container? Well, a lot of times your core application code will be running inside the container, but you have other things that your application code needs to talk to. So for example, if it's a web server, maybe it needs to talk to a database to persist the information. Let's say it was like a game server. We're broadcasting this on Twitch. A lot of people are probably familiar with that concept of a game server that you connect to. Well, let's say that it needs to store the high score somewhere. Or let's say that you're playing an MMORPG and it needs to store state about your character's level and items and stuff like that. Well, the core application code will be running inside the container, but then that container needs to be able to talk to a database or somewhere to actually save that information in case the application stops and needs to be restarted. Otherwise, it would just lose all your information and it would be gone forever. So the idea with this local container testing is it allows developers to more gracefully run that same server locally on their laptop and test it against the remote cloud database, as well as on the ECS server in the cloud. And in both ways, it allows them to speed up their development time to getting a new feature added or a bug fixed, because they don't have to wait to upload their code to the cloud, wait for it to run and be provisioned, and then test and see what happens, and then come back. Instead, they can just make a change to a line of code and restart very quickly. As you saw in the demo, it was maybe like a second and a half before it came up. So realistically, that makes it much faster for me to write a line of code and then verify that it actually worked or fixed a bug, and then go back and try again if it didn't, versus waiting maybe 5-10 minutes to go all the way to the cloud, upload it, wait for it to be rolled out across a fleet of instances, and then test it. So this is all about productivity and driving your experience much faster to the experience of just working locally with your IDE and writing a line of code and seeing results.
Yep.
Cool. I think that makes sense. I mean, there's still a good amount of confusion. It's hard to explain like cloud computing to containers to local testing in just a few minutes. But I think that was a pretty good job. So hopefully there's a bit less confusion out there.
Trying to give the high-level overview there.
Yeah, we'll have a blog post coming out soon, so you can always check, stay tuned and like check that out.
So this just launched today?
That's right.
Well, that's fantastic. Is this the announcement here on the Launchpad?
That's correct.
Oh man, we should have made way more noise about this. Right on. Good work. Well, that's exciting.
We did it.
So you just got to see the world premiere of this local endpoints for ECS.
Probably the first time I have demoed this live. So
ECS,
I'm glad it
CLI
worked.
local.
That's
Never
right.
forget. We have a few. We have about a minute left, but I had a question that's kind of been burning at the back of my mind.
go
As
for
we've
it.
been talking about this, how this applies to ECS, I know that anybody who followed the keynote earlier today or the recap saw that Werner had this slide up where he was showing the entire container lifecycle, where at the orchestration layer we have ECS and we also have EKS. So can you just very quickly touch on what are the similarities and differences between this kind of workflow between ECS and EKS?
Yeah, so Kubernetes has had something called Minikube for a while. And the idea behind that was it allows you to launch a Kubernetes service and pods locally on your local machine. So this is very similar. It's kind of an ECS native take on it. So it does some of the same things, the same way that Minikube would allow you to launch a pod using your YAML definition locally. You can launch your task definition JSON locally on your laptop. The thing that is not currently implemented is the idea of perhaps scaling out or like service discovery, a few of the ECS features. And so we want to come out with one first pass here to give developers a chance to try it out, and then let us know what else they are missing that they would like us to add, so we can add the most requested and most needed things fast, basically in order. But eventually our goal is to bring that whole experience much closer to your local laptop. And this is our first take at how can I take that task JSON and make it something that works on my local machine, not just in the cloud.
Well, and I think that's kind of the superpower that we have, is that the roadmap is out there on GitHub, that we're prioritizing customer feedback to define that roadmap, and then we're able to build out these features really rapidly, whereas with something like Minikube, we have less control over influencing that thing, and if there's a missing feature, we can't add that as quickly. So,
well, just like with Kubernetes, there's like a SIG group that you can join to contribute product ideas. That's basically what we're trying to do also with our open groups and open discussions on GitHub.
Yeah.
So we're working on getting closer and closer to the community there and getting more feedback and being able to iterate faster on that. So it's an ongoing project.
Yeah, awesome. Well, I think that's all the time we have. And thank you very much for being here with us. This is an exciting announcement. ECS CLI Local. Check it out, Twitch. We'll be right back.
All right.
See ya.